All right. So let's start by looking at the quiz we had the last 2 weeks. Okay, we couldn't meet online last week. Okay, so let's go through the quiz. So for the A class, there were some questions that were asked. So list 4 features of the MATLAB environment. Okay, so the MATLAB environment has the command prompt, has the line continuation ellipse, has the workspace, has the command window, has the arithmetic operators, the command um, history window, and so on. Please, are you all with me?
Yes, sir.
And there was a question on how many types of arrays to state them. So we have 2 types. The vector, that's the 1 dimension, and then the matrix array. Then we looked at another question was to list 3 features that can be added plots in MATLAB. So there is the can add the title, grade, text, stuff. When we came to quiz 2, still on the
Sir, please, we can barely hear you.
The person who said he can barely hear, is it better?
Yes, please.
Okay. All right. So quiz 2, we're given a matrix, and you are supposed to write the matrix or the MATLAB of that equivalent to that matrix. Okay. So it was a 3 by 3 matrix. Okay, so in order to represent it, you have to start with the square bracket. Okay, and I noticed most of you using curly brackets and the normal brackets. I think I pardoned most of you who did that. However, going forward, exams and so on, if you write it without the square bracket, okay, it's going to be wrong. So please take note of that. Please take note of that.
Hey, Bob, nobody. How many in the class?
Please, when you join, kindly mute your microphone so that you don't disturb the flow. Yeah. All right. So we said that anytime you have a matrix, okay, so from the question we're given, and it's a 3 by 3 matrix, you take the first row, then you separate it with a semicolon. Then you take the next row, values within the next row, separate it with a semicolon. And then in this case, we take the third row. So this is the answer for the question. And the next question was on what MATLAB command is used to determine the size of the matrix. Okay, and this is the MATLAB command. I's into brackets A. So the matrix was given as A equal. So you do size into brackets A. And the next question says, write a MATLAB command for the list of numbers from 2 to 20. Or even numbers from 2 to 20. So we know even numbers, if they are starting from 2, the interval or the incremental value is 2. So we use 2 here. So we start from 2, the initial value. Then the final value is 20, which will be given. However, because it's an even number, if you are starting from 2, the next number has to be 4. An increase in that order of even numbers, 4, 2, 4, 6, 8, and so on. So this is the MATLAB command for that. The next question said you should state and describe two characters used in array operation. So there is the column, which is used in shortcut expression, as we can see in question 2. Then there is the assignment operator. There is the subscript for arrays. There is the bracket, which is a square bracket for array forms, or that forms the arrays. There is the comma, which separates the elements in the array, so we can see that being used. There is a semicolon, which suppresses echo of input, or it ends the row of an array. Okay, as we can also see in this example. Then there's a single quote, which is used to find the transpose of array, or matrix transpose of an array, or it's used to create a string. It's used to create a string. Now, the last question says you should find the syntax for branching and conditional statements in MATLAB. Okay, so it says if, which was the last topic we treated before the main semester, for the quiz. So if, then it comes with a logical expression. So let's say if B is less than C, it should execute statement in here, else it should execute statement B. Then you end your if statement. Okay. Now another way of also representing it is in this view, where it's in a straight line. However, you separate it with comma. Okay, so if the logical expression, that is if, for instance, A is less than B, okay, then we execute statement A, else we execute statement B. So that was for the A class. Now to the B class, questions were also in a similar fashion. So list 3 predefined variables in MATLAB. So there's a pi, there's I, there's j, there's infinity, there's not a number, none, ans, real max, real min, eps, block, dates, and so on. Then list 5 built-in elementary MATLAB functions. Elementary math functions in MATLAB. So there's the abs function, there's the square root, there's factorial, there's log, there's 10, there's exponent. Okay. And next question says state 2 command function used in arrays. So there's the size of an array, it's also the length of an array. The final part of the question for the quiz, you were also given a matrix, which was, I think, a 2x4 matrix, a 4x2 matrix. So 4 rows by 2 columns. Okay, so for each row, 2, 1, 2, we separate with a semicolon. 3, 4, separate with a semicolon. 5, 3, separate with a semicolon. 4, 3, 4, being the last row. Okay. Like I said, with the A class, the B's also, a lot of people had this particular question wrong. People were writing certain things. Apart from the fact that a lot of people were using the normal brackets and the curly brackets, in which I overlooked mostly. Okay, but once the values you are entering inside are completely wrong, some people were using colon instead of the semicolon. So then the next question was to come up with a MATLAB function that can find the length of matrix B. Okay, and this is the MATLAB function, the length of matrix B. And it says write a MATLAB command for a list of numbers from 0 to 100 with an interval of 10. Okay, so if we start from 0 and we are ending at 10, we use the shortcuts, that's and then introduce the interval, which is 10. Okay. Now we know that by default, the interval is 1. Okay, so if you don't bring this 10 here, what happens is that instead of counting from 0, 10, 20, 30, if you don't bring the 10 here, what will happen is it will count 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, all the way to 100. Okay, so this is what determines the interval, just like in the question for the A class, they have to do with even numbers. So the term even numbers here.
When I go, I'm going to do something.
Oh, you have to verify this correct.
Or there's the phrase even number here should let you know that we are dealing with interval of 2. All right, then the other questions still flow, just like for the A classes, 2 characters used in array, right? The syntax for branching and conditional statements. Please, any questions? Any question?
No, sir.
If you have a question, you can bring it up.
Okay.
The part-timers also had a different set of questions as well. Maybe we should go through that and look at news today. All right, so the part-timers list 5 features of the MATLAB environment. Okay, so just like the A class also had. Then the other question, what is the difference between variable? Okay. Now we know variables are used username that refer to a particular location in the computer's memory. So you can have a variable A, a variable B, and so on. Okay. Now, the data type is a set of values together with its operators, or in a particular kind of data item as defined by the values it can take. So that is to say that if the value is a numeric value, then it's a numeric data type. Okay. If the value is a character, okay, there's a character data type. So value is a string, which can be maybe your name being a string, and it will take it a data type in that particular fashion. And their next piece also, they were given a matrix 2 by 4 matrix. Okay, that means 2 rows, which this is the first row, then this being the second row. Then they were told to, I think there was a mistake here, but the question has to do with determine the dimension of the matrix. So the dimension of the matrix B is a 2 by 4 dimension. Or it's a 2 by 4 dimensional matrix. Now, what's the difference between a row vector and a column vector? And then you're supposed to state that with an example. Now, we know that matrix have a matrix having only one row is known as a row vector, whereas a matrix having only one column is known as a column vector. Okay, now, but I'll appreciate this definition a lot, which says that a column vector is given by 1 by n array, okay, where 1 by n is like you saying, or you giving an array in this form, which is a 2 by 4 dimension, okay, which is a 2 by 4 dimension. So in that case, if you say a row vector is 1 by n, that means that the value of 1, which is the row part, okay, it has only one row, like we did in this definition. Okay, but the columns can be more than one. Okay, whereas with the column vector, it has is n by 1, where n is the number of rows. That means the rows can be from 1 up to infinity, whereas the column is just 1. Okay, so this is describes the difference between the row vector and the column vector. Okay, then with the example, as we can see, as we have in the handout. So that was the quiz we had, and the handouts have been marked. I expect us to meet today so that we go through it and programs. However, lab is being used for mid-semester receipts examination, so we have to it's online. All right, any question on the quiz before we look at loops? Any question? Any question? Please, on the 14th, that's 2 weeks from now, we will have our mid-semester exams. Okay, we will have our mid-semester exams, so kindly take note of that. On the 14th, we will have our semester exams. So please keep that in mind. All right, so if there's no question, let's look at loops. We'll skip plotting and graphs. Okay, we'll skip it, but I want you to read on it. Next week, we'll meet face to face, and we'll look at functions. Okay, one of the most important topics, relevant topics that we need to look at. But today we are looking at loops. All right, so what are loops? Okay. Basically, in terms of programming, like I said in the previous lecture, it has to do with taking inputs, you process the inputs, then it gives you an output, or you display or print your output. Okay. Now, depending on the type of problem you have, there may be a need for you to take some decision. Okay, so that was what led us to the branching statement, where you have to take a decision. Okay. You have to take a decision, and in that case, it's either the decision is true or false, and it is based on some conditions. Okay, so we looked at some of the conditional operators, and then we also looked at the logical operators, the and, the or, the not. Okay, so you have the video, you can always go back and refer to them. Okay. Now, another aspect of, that concept is in computing or in programming known as control structures. Okay, they help you control the program based on the problem you are solving. So the one is the branching and the conditional statements, okay, which we saw a question of that in the quiz. Okay. Then the other one is what we call the loops. Now, the branching and conditional statement, they execute statement if the condition is met. Okay, so if the condition is met, it will execute the statement. However, with the loops, they execute a statement while a condition is met. Now, we say while a condition is met because loops are repetitive. They repeat themselves, or they are iterative. Okay, so if, for instance, you have a program which wants a particular task to be repeated 10 times, okay, then you use a loop to accomplish that particular task. Okay, so for instance, you have, let's say, 10 materials which you need to find, use an equation to find, let's say, the strength of those materials. Okay. Instead of running, using that function once, and then you have to run the function over and over again for 10 times. Okay. In loops, you specify a condition, okay, which was like, okay, I want this particular function to repeat itself 10 times in order to calculate the strength of the material given. Okay, so it's not like you do it once, you stop, you enter the function again to calculate, you stop, you get the answer, enter the function again to calculate, and so on. When you do it that way, it's time consuming. Okay? So we use the loops to just capture the function at just one instance, and then it will automatically repeat itself the number of times you want without you doing it manually. Please, I hope you are all following. Hello?
Yes, sir.
All right.
Yes, sir. Sir, we are here.
Yes, sir.
Yes, sir, we are here.
All right. Now, let me just go through this aspect of the material quickly. In designing or in problem solving, there are techniques that we use, okay, to design the problem. Basically, what we call algorithms. Now, these techniques can be taken from two approaches: the top-down approach or the bottom-up approach. Okay, but in this case, we are focusing more on the top-down approach. Now, with the top-down approach, it is a process of starting a task. It's a process of starting a task with the largest task and breaking it down into smaller bits, which makes it easily understandable in order to find a solution to the task. Okay, so with the top-down approach, you are breaking whatever problem you have into smaller pieces, okay, which is more easily, which can be understood easily and then used to solve the problem. Okay. Now, once the program is divided into these small pieces, each piece can be coded and tested individually. Okay, so in terms of programming, there's something called divide and conquer. Okay. If you have a problem, there are techniques that we use where we divide the problem to small pieces, and then we tackle each piece as a particular, as a unit, okay, to make it easier to solve the problem. Now, the problem design process goes through this approach. First, you clearly state the problem that you are trying to solve. Then you define, okay, a type here. You define the inputs required by the program and the inputs to be produced and the outputs to be produced by the program. You define the inputs. So what are my inputs? What are my outputs? Okay, we'll look at these steps a lot next week when we are looking at functions. And you design the algorithm you intend to implement the program. Now, what is an algorithm? Algorithm is a step-by-step procedure for finding the solution to a problem. Okay, it's a step-by-step. So step 1, do this. Step 2, do this. 3, divide this by this. Step 4, out the result, and so on. That is what we call an algorithm. Okay? Now, after getting your algorithm, the next thing you do is to turn those algorithms into MATLAB statements. Turn the algorithm into MATLAB statements, and then you test the resulting program with some values or with some input to see whether they actually are accomplishing the task you are solving. Okay, so that's the algorithm. Now, in some books, they are also described by using what we call pseudocode. Pseudocode. The word pseudo here means false or not genuine. Okay, or fake. Okay, so pseudocode is a false code. So, in that we are writing a program in MATLAB, writing some codes in MATLAB. Okay, the pseudocodes here mean that they are not the actual codes. Okay, they are just maybe some English word to represent what the actual codes are doing, okay, but not necessarily the actual code as in the MATLAB code, but some false code which are expanded in to help you understand what is happening. Okay. Now, these are used in the branching and loops problems, okay, or control structures. All right, so let's look at loops. Now, it says one of the strongest attributes of computer is its ability to do fast, repetitive operation on a set of data. As programmers, we use this feature to loop when we want to repeat certain program over and over again. Okay, for instance, we want to calculate the sum of all the elements. The sum of all the elements of an array A. Okay, And we do that by using what we call the brute force approach, which is the basic approach to solving a problem. Okay, so with a brute force approach, we are doing something directly, okay, with a physical strength directly, without any mechanical help or any sophisticated method. We are doing direct. Okay, so in this case, if you want to, let's say, find the sum of A, okay, what we would have done is to do A1 plus A2 plus A3 plus A4 all the way to AN. Now, if your N here is, say, 10,000, that means you are going to repeat this tax plus this plus this plus this all the way to 10,000, which is not considered as an expert, okay, way of handling the program. Okay, it's not considered as the right way of handling the program. Now, mind you, handling it this way doesn't mean it's wrong. It doesn't mean it's wrong. However, what is happening is that you are going to spend a lot of time, okay, inputting the values and adding it one by one, okay, which is called the brute force way. It was directly, okay, and it's not the best. Okay. However, another way in which you can write the same expression is to say that sum A equals 0. Okay, now sum A, which is 0, or sum A equals sum A plus A plus 1. That means 0 plus A1. Okay, then this will repeat. Okay, so if we say A1 is A1, A2, A3 is the elements in the array. That means that we put the A, okay, so that the equation, which is A, sum A equals sum A plus A, will repeat itself provided there's a value for A. Okay, so this will keep repeating itself until what? You get your final answer. Okay. I said here that clearly this will be insufficient for large arrays. Okay. However, there's a repetitive pattern for the above which can be expressed by using this formula. Okay. So we've been given the formula. Okay. Now, how do we achieve that? We achieve that by first saying that what? Our sum A is equal to 0. Okay. Now, with the loops, we have one of them known as the for loop. That's one of the most used loop, the for loop. Now, for I, where I is a variable, equals to I, okay, to N. From 1, sorry, equals to 1, semicolon, sorry, colon to N. That's from 1 to N. It means that whatever value we give to N, whether 10,000, we don't need to write the code this way, this number of times, or please mute your microphone, Michael, up here. Or in this way, okay. Doing it this way, we are going to add it a number of times. However, when we use the for loop, okay, we specify the number, which is the 1, 2, 3, the way to N here. We specify it in the for loop and say that I or I equals 1 to N. Okay, we set this parameter down, and then we put in the formula, which is the sum A equals sum A plus A, and then we substitute the value II in here. Okay, so this will perform this automatically without you having to repeat this statement 10,000 times. Please, I hope you are all following. I hope you are following.
Yes, sir.
Yes, sir.
All right. Okay. So that is how loops work. Let's look at the syntax for loops. So the general syntax is from this form. So you are given, we have the for loop. So for index equals to expression. So index means the value of the location of the value. Okay, and they are given the expression. So the expression can be 1 column n, 1 to n. Okay, then within it, you are given a statement, which is the body of the loop, a statement to execute, and after that, the end. Okay, so there's an example here. Calculate the summation of 1, 2, 3, 4, 5, all the way to 100. Are we all here? Are we all here?
Yes, sir.
Okay. So let's try this in a program. Let's try this in a program. So I have my MATLAB open. I hope you can see. I want to divide the screen into two so that you see what is happening. So we are saying that what we want to calculate the summation of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 100. Okay. Typically, if I have a calculator, sorry, if I have a calculator,
Sound boss.
okay, what I would have been doing is to say 1 plus 2 plus 3 plus 4 plus 5 plus 6. This is the brute force way. I hope you are all following. Okay, plus 10 plus 11, okay, plus 11 and so on. You are supposed to do this all the way to what? And that is what the question is requesting. Okay, that is what the question is saying. Okay, so how do we write it in a form of a loop? Okay, so we don't need to be doing 1 plus 2 plus 3 plus 4 plus 5 and so on. Okay, so simply put, we have the variable, which is what? Sum. Okay, so we say sum equals 0. Okay, now sum equals 0. Now, for II, okay, which is just a variable name, or we can say for index, equals, now we introduce our expression. We are starting from what? We are adding values from 1 to 100. Okay, so we specify 1, and our column, what? 100 to 100. Okay, and then we say sum equals sum plus index. Now, what it means is that the value of sum is 0. Okay, the value of sum is 0. And the value of index is from 1 to 100. Okay, so let me just finish and then explain this. And then we end. Okay, we end the program. So basically what we have here is how we represent the loop. Now, the sum here is 0, okay? And the index here is from 1 to 100. So what is going to happen is that at the first iteration, or the first time the loop runs, it will run with a value of index as 1. Okay, so you are going to get sum equals 0, which is the value of sum, 0 here, plus index, where the initial value of index is 1. Okay, so that will give you the value of sum to be 1, 0 plus 1 to be 1. Okay, let me just use a whiteboard to explain it much better. So, type this in here. We have sum equals 0. Then it says for index is equal to 1 to 100. Then sum equals sum plus index. Then we end. So this is the code. Now, what's trying to say is that the index starts from 1, okay, to 100. Okay, that is to say that this loop has to run or repeat itself 100.
The right message for the lab.
100 times. Okay, it has to repeat itself 100 times. Why? Because we are starting from 1 to 100. Okay, so instead of doing 1 plus 2 plus 3 plus 4, which is the brute force approach, all the way to plus 100. Please mute your microphone, eh? Don't speak it. Okay. What it means is that for index equals 1, so when index is equal to 1, it should come and execute the statement in here. So the statement is saying sum equals sum plus what? Index. Okay. Now we know the initial value of sum, which is what? 0. So you get 0 plus index. The initial value of index is 1. So that gives you a new value of sum as what? As 1. Okay, so sum will now be 1. And when your index is now equals to 2, okay, so the loop will repeat itself again. So starting from 1 to 100. So the next value of index will be 2. So 2, then it will repeat the statement sum equals sum index. Okay. Now, what is the value of sum? The value of sum is now the last value we got from here, which is 1. Okay. 1 plus index. What's the value of index? Who can help us? What's the value of index?
2.
2. Okay, so 1 plus 2. That will give us what? 3. Okay. Then the loops repeats itself again. Okay, it repeats itself to when the index is 3. It's equal to 3. So sum will be equal to sum plus index, where this index is now, where the sum is now 3. Okay, so the new value of sum will be 3 plus the index, which is also what? 3, giving us 6.
6.
Okay, then the loop will repeat again. So it will repeat when what? The index, the new value of index will now be 4. When it is 4, sum will be equal to sum plus index. Okay, now our sum is what?
6.
Sum is 6.
6.
So 6 plus index, which is 4, will give us what?
10.
10. Okay, so this will continue all the way to 1, all the way to when index is equal to 100.
100.
Okay. That's what the condition or the expression we've given here. Okay, so this will add, so sum equals sum plus index. So then the value we had for sum when the index was 99 will be given to the sum here plus what? 100. Okay, to give you your final answer. Okay. Now, what is happening here is that you don't see the manual or the direct approach where you would have been doing 1 plus 2 plus 3 plus 4 plus 5, just like I introduced with the calculator. However, the program will handle it 100 times without you even noticing what is going on. All you realize is that you get your final answer. Okay. So that is how loops are represented. Just indicate where you are starting from, the number of times you want it to repeat itself. Specify the condition or the expression in here, and then put your statement in here. If it's a formula to find maybe the strength of some materials, you have 10 materials, so you do from 1 to 10, and then you put your formula here. What it will do is that it will repeat that formula 10 times in order to calculate the strength of a material. Okay, so that is it. Okay, so we'll run this code. Okay. So I'll put a semicolon there. Okay. So it's giving me the value of sum, which is 510. Okay, the value of sum, which is 500. Because I didn't put a semicolon there, it repeated it for me throughout. Let's play and do it again so that the works starts. So we have sum equals 0. So we see the value of sum here as 0. And then we say for index equals this, sum equals to this, and then we end. So the index is given as when the index 0. Okay, the value of sum is 550. 5,050. Okay, so that is the answer. I hope it's well understood.
Yes, sir.
Yes, sir.
All right, so I won't bombard you with so many things. We'll leave it here. There are some few examples in the handouts. I want you to try them out. There's also what we call the while loop. So read on it. There are some examples here. When we meet in class, we'll try out these examples before the functions. In fact, I'll introduce you to the functions and then use that approach to try this out. Okay, so I think that will be for today. Any question? Any question? Any question? All right, so if there's no question.
When we look at the video.
Yeah, I'll upload it and then share it with your classrooms.
Okay, so thank you.